Find the critical or stationary values of the function f x y z, that is equal to x square plus y square plus z square, given that z square is equal to xy plus 1. So here we have to find out the critical values of the given function, that is your x square plus y square plus z square, and the constraint or condition is given z square is equal to xy plus 1. We will solve it by using the constraint optimization using Lagrange multiplier. We know in the constraint optimization using Lagrange multiplier, the function can be defined as fxyz plus lambda phi xyz. And here the given function or the objective function is given x square plus y square plus z square, and lambda is the Lagrange multiplier, and phi xyz is the constant or condition. So you can write the equation like this: x square plus y square plus z square plus lambda into z square minus xy minus 1. This is the conditional equation. So what are the steps we have to follow? We have to take the partial derivative of this function with respect to x, then y, and then z to 0, and you solve it. If you find out the partial derivative of this function with respect to x, then you will get 2x, then here lambda y, so minus lambda into y, that is equal to 0, so lambda will be equal to 2x divided by y. Suppose this is equation number 1. Similarly, if you find out the partial derivative of the function with respect to y, then this will be equal to 2y minus lambda x will be equal to 0, or lambda will be equal to 2y divided by x. Suppose this is equation number 2. And if you take the partial derivative of the function with respect to z to 0, then partial derivative of this with respect to z will be equal to 2z plus lambda into 2z equal to 0. So lambda will be equal to minus 2z divided by 2z, that is equal to minus 1. This is equation number 3. And from equation 3 we have got the value of lambda, which is equal to minus 1. So if you put the value of lambda in this equation 2, then you can find out the relation between x and y. So putting the value of lambda, that is equal to minus 1 here, you will find out x will be equal to minus 2y. And if you put the value of x in the constraint equation, that means in the we have given the constraint equation z square is equal to xy plus 1. So if you put the value of x in this constraint equation, then what you will get? You will get z square. You will get z square will be equal to minus 2y into y plus 1. So that will be equal to minus 2y square plus 1. So we have got the value of z, and if you can find out the value of x, we can find out the value of y, etc. And we are given that the function f xyz is what will be the critical value. We have to find out the critical value of this function f xyz, and the function is given x square plus y square plus z square, and x is equal to minus 2y, so x square will be equal to minus 2y square plus y square, and z value as we have found out here minus 2 minus 2 y square plus 1. So z square is equal to minus 2y square plus 1. So if you simplify it, this will be equal to 4y square, and here 2y square, 6y square, and then y square, 7y square plus 1. So the function will be equal to 7y square plus 1 given function. And since you have to find out the critical value or stationary value, and at the critical value the derivative of the function will be equal to 0. So if you find out the derivative of this function, that is 7y square plus 1, that will be equal to 14y, and the derivative 14y will be equal to 0. So what will be the value of y? Y will be equal to 0. And if y will be equal to 0, you look to this equation, then x will be equal to 0. So if y equal to 0, x equal to 0, and if you put the value of y here, and that is 0, then you can find out the value of z. So z square will be equal to minus 2y square plus 1. So this will be equal to square root of 1. So that is plus minus 1. So we have three values. We have got three values, one for x, another for y, and another third one for z. And you have two coordinates. One is 0, 0, 1, another 0, 0, minus 1. So you have two coordinates 0, 0, 1 and 0, 0, minus 1. So the critical values of the function f x y z is 0, 0, 1 and 0, 0, minus 1. At these 2 points, the given function x square plus y square plus z square have critical values with the given condition, that is z square is equal to xy plus 1.